Alright, here's another example for integration by parts. This will be example 2. Here's the following problem, your favorite trig. And this will require integration by parts because if we try to make, just use direct substitution and we let u equal 2 minus 3x, that derivative would be negative 3. So we end up with this extra x in this problem. So we're going to make our u be this quantity right here, and then this will be our dv. And remember that formula for integrating by parts is s u dv will equal u v minus the integration of v du. So that's the formula. So if u equals 4x, then du equals 4dx. Oh, and this should be this is a dv right here, sorry. And if our dv is cosine of 2 minus 3x dx, then to find v, we need to integrate all of this. And to integrate this, we're going to need to use substitution, and I'll do that over on the side. So to integrate this, we'll let u equal 2 minus 3x, and du will equal negative 3 dx. So we'll have the integration of cosine u, and see how we have this extra negative 3, so it'll be negative 1/3 du. So we integrate that, we're going to end up with negative 1/3. The integration of cosine is sine. It'll be u, but we're going to put the 2 minus 3x back in. So we'll go back over here. Now we can put in that v actually equals negative 1/3 sine of 2 minus 3x. So now we have the integration of u dv, which is our original problem, will equal u times v. So now I have my u, it's right here. Now I have my v, and then the integration of v times du. So we'll write that out. U, which is 4x, times v, which is negative 1/3 sine of 2 minus 3x minus the integration of v, which is negative 1/3 sine of 2 minus 3x times du, which is 4 dx. Okay, so this is what I had left on that last page. Now I'm just going to simplify this a little bit. So I end up with negative 4/3 x sine of 2 minus 3x. This will turn into plus 4/3 the integration of sine 2 minus 3x dx. So now the only work I have left to do is to evaluate this integral right here. Alright, so to do that, basically right here, I'm going to need another substitution. So u will equal 2 minus 3x, du will equal negative 3 dx, so negative 1/3 du equals dx. So I have the integration of sine u, negative 1/3 du, which will give me negative 1/3 and then the integration of sine is negative cosine, so I'll make that a positive. Instead of u, I'm going to put 2 minus 3x. So I'm going to end up with plus 4/3 times 1/3 cosine of 2 minus 3x. Now I just have to bring that down and then do some simplifying. So I end up with negative 4/3 x sine 2 minus 3x plus 4/9 cosine of 2 minus 3x. And that is done. The only part I would have left to do would be the check. And I'll do the check on the next page. Okay, here's my check part. Here was my original integral, and here was my answer. And I should have a plus c there that I need to squeeze in. So if I take the derivative of this right side, it should take me back to what I have here on the left side. So I'm going to have to use a product rule on this first part right here. So first times the derivative of the second. So second is a composite function. Derivative of sine is cosine. Chain rule. Derivative of 2 minus 3x is going to be negative 3. So there's first times derivative of second plus second times the derivative of the first, which would just be negative 4/3 plus 4/9 times the derivative of cosine 2 minus 3x, which will be derivative of cosine is negative sine 2 minus 3x times, okay, and here's a chain rule, derivative of negative 3x will be a negative 3. Now from here I just need to simplify, clean this up. So let's see, this negative times this negative will make a positive. This 3 and that 3 will make a 1. So I'm left with 4x cosine of 2 minus 3x. And let's see, over here I'm going to have plus negative, or just a minus. Minus 4/3 sine of 2 minus 3x. And then this negative and that negative will make a positive. That 3 will make this a 3. So I have plus 4/3 sine of 2 minus 3x. These are opposites, so they make 0. So I'm left with 4x cosine 2 minus 3x. Yay, checks, it worked.